Greetings Calc 2 students. This video is for section 11.5, specifically with alternating series. The definition of an alternating series. An alternating series is any series whose terms alternate, plus minus, plus minus, plus minus, or minus plus, minus plus, minus plus. So, for example, look at this series. 1 minus a half plus a third minus a fourth plus dot dot dot. So this is plus, minus, plus, minus, plus, minus, and so forth. This series in closed form is written as a summation as n equals 1 to infinity of minus 1 raised to the n minus 1 times b sub n. So we have a test for convergence. So if an alternating series is the summation from n equals 1 to infinity of minus 1 raised to the n minus 1 times b sub n, where that b sub n is positive, or if we have the situation of n equals 1 summation to infinity of minus 1 raised to the n times b sub n, where the b sub n is positive. The only difference between these two situations is if we're going to start with a positive or a negative. So let's look at this first one, n equals 1. When n equals 1, we start with minus 1 raised to the 1 minus 1, which is minus 1 raised to the 0, which is positive 1. So in this particular case, when we start with minus 1 raised to the n minus 1, our first term would be positive, and then negative, and then positive, then negative, and so forth. In the other example, we're starting with n equals 1, and in this case we have minus 1 raised to the 1, and minus 1 raised to the 1 is minus 1. So when you have minus 1 raised to the n, this is a situation where you have minus 1 starting. So you start with negative, and then positive, then negative, and then positive. So those are our two types of alternating series, starting with positive or starting with negative. And then, of course, the b sub n part, this part, has to be positive, always bigger than 0. If our series satisfies these two conditions, then it's convergent. The first condition is that a b sub n plus 1 is always smaller or equal to b sub n for all n. We say that b sub n, the series, is decreasing. So b sub n plus 1 is smaller or equal to b sub n for all n. We say that it's decreasing. So that's the first thing it has to satisfy. The second thing it has to satisfy as the limit as n approaches infinity of b sub n is equal to 0. So if it satisfies both of those conditions, then the series is convergent. So let's look at an example. We're asked to test the series of the summation n equals 1 to infinity of minus 1 raised to the n times 2n divided by n plus 4. So the first thing I want to think about is what is my b sub n. So my b sub n is equal to 2n divided by n plus 4. That's my b sub n. So b sub n is that part. Okay, so then the solution is, the first part is, do I have the situation where b sub n plus 1 is smaller or equal to b sub n? Well, what I like to do is actually skip that part and move on to part 2. Because proving that the series is decreasing can sometimes be difficult. So I like to prove part 2. Get the easier part out of the way, as I like to think. So in this case, what we're having to prove in the part 2 is the limit as n approaches infinity of b sub n is the same as the limit as n approaches infinity of 2n divided by n plus 4. So I'm going to take the limit as n approaches infinity and multiply both top and bottom by 1 over n. So n plus 4, 1 over n. So I multiplied both top and bottom by 1 over n. And then the top of my fraction simplifies to just 2. And the bottom of my fraction simplifies to 1 plus 4 over n. So now when I apply that limit, I just get 2 over 1, which is equal to 2. And of course, 2 is not equal to 0. So it fails the second condition. So it fails the test for convergence. So in fact, the test for divergence that we looked at in 11.2 says that the limit as n approaches infinity of a sub n, which in this case would be the limit as n approaches infinity of our whole thing, the whole thing is a sub n. If we applied that limit, that's not equal to 0, so it would be divergent. And even more precisely, this limit, minus 1 raised to the n times 2n divided by n plus 4, doesn't even exist. So that does not exist, so certainly not equal to 0. And so this is divergent. So then I would say that the series that we're looking at is a divergent series. So I did that by doing step 2 of the solution, and I skipped step 1. But since step 2 failed, then the solution would be that it's divergent. Example number 2. Test this series, minus 1 raised to the n, e raised to the minus n, from 1 to infinity, summing those up for convergence. So once again, I like to skip to the second part first and see if the second part passes, and if it does, then I move on to the first part. So the limit as n approaches infinity of b sub n is equal to the limit as n approaches infinity of e raised to the minus n. So this part, e sub n, or e raised to the minus n is b sub n, is equal to e to the minus n. Well, then that's the limit as n approaches infinity of 1 over e to the n. And if we did that, that would be exactly equal to 0. So it passes part 2 of our solution test. So now we need to have part 1. Well, part 1 says is b sub n plus 1 is that smaller or equal to b sub n for all n. So b sub n is equal to 1 over e to the n, and b sub n plus 1 is equal to 1 over e to the n plus 1. And then the question then becomes, is b sub n plus 1, is that in fact smaller or equal to b sub n? That's the question. B sub n is decreasing, right? If I look at the second one, b sub n is 1 over e to the n, so n gets bigger, n plus 1, the denominator gets bigger. So b sub n, that series, is decreasing. So since part 1 passed and part 2 passed, then I would say that this series is convergent.